All right, so let's wrap up. Oops, sorry, this should be 11.7. This is our last section of the semester, all right, of the summer. So let's wrap it up. A lot of good math going on here. Review of some old ideas, etc. So lots of putting things together. And what we're going to be doing is we've just learned how to graph in standard form. Nice and easy. I can find my vertex. The A tells me what I'm doing, upwards or downwards. Not too bad to find the y-intercept. So pretty easy form to graph with, as opposed to the general form. If I was to give you something in general form right now, the best way to graph it is to point plot. And you just keep point plotting until you see all the things you're supposed to see, etc., which is kind of hard when it comes to the vertex. So the question is there a way to go from the general form to the standard form? And the answer is yes. There's actually two ways we can do this. One is the ground and pound, lots of algebra, lots of math stuff, which is where all the good stuff's at. All right, especially if you guys are moving on to more math. So knowing these steps will be essential in some areas. And then there's going to be an easy way. Turns out that there's just a formula. So we're going to first do the completing the square process. It's going to be a little bit modified. So let's just kind of remind ourselves what that step is. And once we go through that process with something like this in general form, we end up with something in standard form, and then again we can easily graph. First of all, why it needs to be modified. The reason why it needs to be modified is because we're used to having a 0 over here. So to balance off an equation, we would usually do everything to both sides. So if I added something over here, I add something over here. If I subtract something from over here, I subtract it from here. If I divide by 3, I divide by 3. And like I said, in the past, we used to have a 0 here. But now when I start, our first move is usually to make sure that this lead coefficient is positive. And we did that by dividing by 3. And so what we ended up with is something like this back in the past. But here we were used to 0 divided by 3 is 0, but I don't have a 0 anymore. I have f of x. So now I got to kind of hold on to that extra, concept, if you would. And then as we complete the square, right, what's going to complete this, we would subtract 7. So now we have f of x over 3 minus 7 equals x squared plus 4x. So we're going to constantly having to hold on to this, and it's going to be hard to reverse ourselves to go back to this. So that's why we actually have to modify it, because this side's not equal to 0. So here's what it's going to look like when we do the modification process. So let me start here, and I'll go step by step and show you the process in this case. So first of all, what we want to do is we want to begin by putting parentheses around the incomplete square. So you'll remember that the x squared piece and the x part, right, those two pieces together usually represent an incomplete square. So I'll begin this journey by putting some parentheses around the part that I'm interested in. So now what I've done is I've isolated the part that I want. This 7 is just kind of out there for the ride. And again, what we usually did is subtracted it, got it over here so we can just concentrate on this piece. But we're doing everything on the same side. Our next move is to factor out the GCF. Now, most often it'll be the GCF, but as you'll see in some later examples, what we're really doing is factoring out the A. Now remember, what I need is I need the lead coefficient to be 1. What we used to do is divide it out to get the 1. But here what I'll do is I'll simply just factor that out. Now, of course, in this case, it is truly the GCF. So when I factor that out, what I end up with is that. Okay? So now, inside the parentheses, I truly have an incomplete square. My lead coefficient is 1, and it's the classic x squared plus, some bx. So now what we're going to do is go through our normal completing the square process. So we would take our 4, divide it by 2. Remember, that number is going to play an important role for us. But then I would square it and get 4. So here's the piece, right? This is the little missing chunk that needs to be added to complete the square. Now, what we used to do is add and subtract it, add it to both sides. But now, right, step 4, we're actually going to add it and subtract it within the parentheses. So I know this is going to look weird, but mathematically, I'm in balance here because 4 minus 4, this is 0. So this expression right here still represents this expression up here on the top. So my equivalency is still in play. So that's the trick that we're doing. So notice everything's being done. On this side, we constantly have f of x, but all our completing the square process is done on the same side. But we're still in balance, because if I had to go backwards, right, this expression is equal to this expression is equal to that expression, and of course this is equal to this. So I haven't lost the equality. This and this are still equal because of my balancing axis that I'm choosing to play. Now what we're going to do is the part that completed the square was the plus 4. This minus 4 is only there to balance that off, right, to get us 0. So we actually want to remove the subtraction part out of the parentheses. But we have to be careful, because sitting outside of this parentheses is this 3. And so what we would probably, if we were going to try to get back up to here, I would distribute that 3 out to everybody, right? 3x squared, 12x plus 12 minus 12. So when I move that 3 out of the parentheses, it's going to be multiplied by that 3 that's sitting outside of the parentheses. So it really comes out of there is the minus 12. And again, if we were to distribute it all the way, 3x squared, we'd get a 12x, we get a positive 12, we get a minus 12. So we want to keep these, we want to keep the 3 out of these 3 terms, but the 3 is going to have to hit that term as it comes out of the parentheses. We're almost done. What we now have is a perfect square trinomial, that guy right there. So we get f of x equals, we get 3, x plus 2 squared, and then negative 12 plus 7 gives us a negative 5. And lo and behold, what do we now have? We've got our form. We've got our standard form. So it looks like the vertex is sitting at negative 2, negative 5. The 3, right, a is equal to 3, so we know we're opening up and we're a little skinny. And so we can basically do all our calculations and all our math. Okay, so there's the process. Again, it's the same completing the square process that we did before. The steps are very similar, but the only thing that's new, the modified version of it, is we're doing everything to the same side of an equation. One last thing that I want to mention is notice that the a that turns out to be in front of these parentheses happens to be the leading coefficient from the very beginning. The lead coefficient was 3, and that a turned into 3. So we could actually tell a lot just by looking at this general form. That a right there tells us right away whether we're opening up or whether we're opening down. Of course, how do we find the h and k? We definitely have to go through this process to find the h and k. Alrighty, so we obviously need to practice this, and we'll do that in the next video.